Hi, hello, welcome to i-TUTOR NCERT series. Today, we are going to discuss Class 11 Geography NCERT Fundamentals of Physical Geography Chapter 2 The Origin and Evolution of the Earth. First one, Early Theories of the Origin of Earth. A large number of hypotheses were put forth by different philosophers and scientists regarding the origin of the Earth. One of the earlier and popular arguments by the German philosopher Immanuel Kant. Mathematician Laplace replaced it or revised it in 1796. It is known as the nebular hypothesis. The hypothesis considered that the planets were formed out of a cloud of material associated with a youthful sun, which was slowly rotating. In 1950, Otto Schmidt in Russia and Karl Weizsäcker in Germany somewhat revised the nebular hypothesis, though differing in details. They considered that the sun was surrounded by solar nebula containing mostly the hydrogen and helium, along with what may be termed as dust. The friction and collision of particles led to formation of a disc-shaped cloud, and the planets were formed through a process of accretion. However, scientists in later period took up the problems of origin of universe rather than that just the Earth or the planets. Okay. Now, modern theories, that is origin of the universe. The most popular argument regarding the origin of universe is the Big Bang theory. Okay. Have you heard about the Big Bang theory? So it is also called expanding universe hypothesis. Okay, so the Big Bang theory is also called a expanding universe hypothesis. Edwin Hubble in 1920 provided evidence that the universe is expanding. As time passes, galaxies move further and further apart. Okay, so the time passes, galaxies move further and further apart. The distance between the galaxies is also found to be increasing, and thereby the universe is considered to be expanding. Scientists believe that though the space between the galaxies is increasing, observations do not support the expansion of galaxies. The Big Bang theory considered the following stages in the development of the universe. Okay, so now let's discuss the Big Bang theories. First one, in the beginning, all matters forming the universe exist in one place in the form of a tiny ball, that is a singular atom, with an unimaginable small volume or infinite temperature and infinite density. Okay, so it form a tiny ball with an unimaginable small volume and infinite temperature and infinite density. At the Big Bang, the tiny ball exploded violently. This led to a huge expansion. It is now generally accepted that the event of Big Bang took place 13.7 billion years before the present. The expansion continues even to the present day. As it grew, some energy was converted into matter. Okay, so some energy converted into the matter. There was particularly a rapid expansion within fractions of the second after the bang. Thereafter, the expansion has slowed down. Within first 3 minutes from the Big Bang event, the first atom began to form. Okay, so within first 3 minutes from the Big Bang event, the first atom began to form. With 3 lakhs years from the Big Bang, temperature dropped to 4500 Kelvin and gave rise to atomic matter. The universe became transparent. The expansion of universe means increase in space between the galaxies. Okay, so what is meant by expansion of universe? It means the increase in space between the galaxies. An alternative to this way, Hoyle's concept of steady state. It considered the universe to be roughly the same at any point of time. However, with the greater evidence becoming available about the expanding universe, scientific community at present favors argument of expanding universe. Now, the star formation. The distribution of matters and energy was known even in the early universe. These initial densities differences gave rise to difference in gravitational forces, and it caused the matter to get drawn together. These formed the basis for development of galaxies. A galaxy contains a large number of stars. Okay. Galaxies spread over vast distances that are measured in thousands of light years. So what is light year? Look at here. A light year is a measure of distance and not of time. Okay, so what is light year? It's a let me okay, it's a measure of distance. Light year is a measure of distance. It's not the measure of time. Light travels at a speed of 3 lakh kilometer per second. Okay, so light travel in a speed of this much kilometer per second. Considering this, the distance the light will travel in 1 year is taken to be 1 light year. Okay, so what is 1 light year? Look at this. Here we discussed about the light years. So what is light year? It is the distance the light will travel in 1 year is taken to be 1 light year. That is equal to 9.461 into 1012 kilometer. This means distance between the sun and the earth is this much big. Okay. Now, in terms of light year, it is 8.311 minutes. Okay, so in terms of light year, it is 8.311 minutes. Now, going back, the diameter of individual galaxies ranges from 80,000 to 1,50,000 light years. Okay, so the diameter of individual galaxies, they range from 80,000 to 1,50,000 light years. A galaxy starts to form by accumulation of hydrogen gas in the form of very large cloud called nebula. Eventually, growing nebula develops localized clumps of gas. These clumps continue to grow into even denser gaseous bodies, giving rise to formation of stars. Okay, so these clumps, they continue to grow into even denser gaseous bodies. Okay, so these gaseous bodies are then formed to stars. Okay, then change into stars. The formation of star is believed to have take place some 5 to 6 billion years ago. Okay. Now, formation of planets. The following are considered to be the stages in the development of planets. First one, the stars are localized lumps of gas within a nebula. Okay, so the stars are localized lumps of gas within a nebula. The gravitational force within the lumps lead to the formation of a core to the gas cloud, and a huge rotating disk of gas and dust develops around the gas core. In the next stage, the gas cloud starts getting condensed and the matter around the core develops into small rounded objects. These small rounded objects, by the process of cohesion, develop into what is called planets imels. Okay, planets imels. Larger bodies start forming by collision, and gravitational attraction causes the material to stick together. Planetesimals are large number of smaller bodies. Okay, so these are large number of smaller bodies. And in the final stage, what happened? These large number of smaller planetesimals accreted to form a fewer large bodies in the form of planets. Now, the evolution of the Earth. The planet Earth initially was a barren, rocky and a hot object with a thin atmosphere of hydrogen and helium. This is far from the present day picture of the Earth. Hence, there must have been some events process which may have caused this change from rocky, barren and hot Earth into a beautiful planet with ample amount of water and a conducive atmosphere favoring the existence of life. The Earth has layered structure. From the outermost end of the atmosphere to the center of the Earth, the material that exists is not uniform. The atmospheric matter has the least density. From the surface to deeper depths, the Earth's interior has different zones, and each of these contains materials with different characteristics. So, evolution of lithosphere. The Earth was mostly in a volatile state during its primordial stage. Due to gradual increase in density, the temperature inside has increased. As a result, the material inside started getting separated depending on their densities. This allowed heavier materials like iron to sink towards the center of the Earth, and the lighter ones move towards the surface. Okay, so the heavier materials like iron sink towards the center of the Earth, and the lighter materials which move towards the surface. With passage of time, it cooled further and solidifies and condensed into smaller size. This later led to development of an outer surface in the form of a crust. During the formation of the moon, due to giant impact, the Earth was further heated up. It is through It is through the process of differentiation that the earth forming material got separated into different layers. Starting from the surface to the central parts, we have layers like the crust, mantle, outer core, and inner core. From the crust to the core, the density of the material increases. Okay, so from the crust to the core, what happened? The density of the material increases. More denser in the core part. Okay, the core is more denser. Now, evolution of atmosphere and hydrosphere. Okay, so first one we discussed about the evolution of lithosphere. Next one is the atmosphere and hydrosphere. The present composition of Earth's atmosphere is chiefly contributed by nitrogen and oxygen. There are three stages in the evolution of present atmosphere. The first stage is marked by the loss of primordial atmosphere. In second stage, the hot interior of the earth contributed to the evolution of the atmosphere. Okay, second stage is the hot interior of the earth, which contributed to the evolution of the atmosphere. Finally, the composition of the atmosphere was modified by the living world through the process of photosynthesis. The early atmosphere with hydrogen and helium is supposed to have been stripped off as a result of solar winds. This happened not only in case of Earth, but also all the terrestrial planets, which were supposed to have lost their primordial atmosphere through the impacts of solar winds. Okay, the solar winds have a large impact on the formation of planets. During the cooling of the Earth, gases and water vapor were released from the interior solid Earth. This started the evolution of the present atmosphere. Okay, so during the cooling time, gases and water vapor they released from the interior solid Earth, and this started the evolution of the present atmosphere. The early atmosphere largely contained water vapor, nitrogen, carbon dioxide, methane, ammonia, and very little of free oxygen. The process through which the gases were outpoured from the interior is called degassing. Continuous volcanic eruption contributed water vapor and gases to the atmosphere. As the earth cooled, the water vapor released starting getting condensed. The carbon dioxide in the atmosphere got dissolved in rainwater, and the temperature further decreased causes more condensation and more rains. The rainwater falling onto the surface got collected in the depression to give rise to oceans. Okay, so this rainwater falling into the surface got collected in the depressions, and this makes the formation of ocean. The Earth's oceans were formed within 500 million years from the formation of Earth. This tells us that the oceans are as old as 4,000 million years. Sometimes around 3,800 million years ago, life began to evolve. Okay, so the 3,800 million years ago, the life began to evolve. However, around 2,500 to 3,000 million years before the present, the process of photosynthesis got evolved. Okay, so the photosynthesis period is evolved before the present year, that is before 2,500 to 3,000 million years before. Life was confined to the oceans for a long time. Oceans began to have the contribution of oxygen through the process of photosynthesis. Eventually, oceans were saturated with oxygen, and 2000 million years ago, oxygen began to flood the atmosphere. Okay, now origin of life. The last phase in the evolution of the earth relates to the origin and evolution of life. It is undoubtedly clear that initially the earth or even the atmosphere of the earth was not conducive for the development of life. Okay, so originally it was not support the life system. Modern scientists refer to the origin of life as a kind of chemical reaction which first generated complex organic molecules and assembled them. This assembly was such that they could duplicate themselves, converting inanimate matter into living substance. The record of life that existed on this planet in different periods is found in rocks in the form of fossils. The microscopic structures closely related to the present from the blue-green algae have been found in geological formation much older than some 3000 million years ago. It can be assumed that life began to evolve sometimes 3800 million years ago. Okay, so that's about the chapter. If you have any doubts, you can comment below. For more videos, do like, share and subscribe.